In previous video, we discussed about the syllabus overlook. So we gone through that, and in first chapter, coordinate geometry, we came across two sections. That is, one is straight lines and another one is conic sections. So now we'll first discuss about the straight line. So welcome everyone to our channel. Please share and subscribe. So first now we'll discuss about straight line. Okay, this straight line, we have seen in syllabus that it is of 14 marks, out of which one question of 3 marks, one question of 5 marks, and one question of 6 marks. So in this straight line, so first we'll have to know about what is inclination. What is inclination? See, in this inclination, see, for example, you have two axes, that is, the one is x and another one is y. You have a line here. Here, if this is theta, okay, I'll take theta 1. You can even take theta 1, or you can even take it as theta. So see, this line is inclining with this x-axis. Okay, if this is measured in the anti-clockwise direction, this will be taken as positive. This theta, okay, measured in this theta is known as inclination. Okay, so this theta is known as the inclination with respect to x-axis. Okay, so keeping this inclination in mind, we'll discuss what is slope and what is a gradient. So see, we'll discuss about slope. Slope is also known as gradient. Okay, it is also known as gradient. This is usually denoted by M. Slope or gradient is denoted by M. Okay, from this, what is M then? What is slope? See, it is the tangent of an angle made with respect to the positive x-axis. See, for example, this is x-axis and this is y-axis. This is a line, okay, this is inclining at some angle, I say it to be theta. So I'll have to find the slope of this line, slope or M of this line. Okay, so I clearly said you, slope is the tangent of the angle made with respect to the x-axis. Okay, that means slope M is equals to, it is the tangent, that means tan of the angle made with respect to the x-axis. So M is equals to tan theta. So usually slope is given by M is equals to tan theta. So now, next is, we now know slope. Now we'll have to discuss about the relation between the slopes of the parallel lines. Okay, slope of the parallel line. Slope of the parallel lines. Okay, see, I'll show you two parallel lines and how the slopes are related. Okay, this is y-axis, this is x-axis. Okay, you have one line here, you have another line here. Okay, I'll take this angle to be theta 1, I'll take this angle to be theta 2. This is theta 1 and this is theta 2. Okay, so now theta 1 and theta 2, we'll see how the slopes of these two lines are related. Okay, see, you can clearly see, if these two lines are parallel, then these angles are going to be same with respect to x-axis. Okay, see, we say lines to be parallel only when it is like this, right? Then so it is, but here it is inclined. That's it. So these two lines are same. If you see it in this way, if you see it in this way, okay, if you see it in this way, see these two lines are similar as these two lines. So these two lines are parallel. If these two lines are parallel, the inclination of these lines with this x-axis is also going to be same. That is theta 1 and the theta 2. That means I'll take it theta 1 equal to theta 2. Theta 1 equal to theta 2. So theta 1 is equal to theta 2 in the sense I take tan on both sides. Tan theta 1 is equals to tan theta 2. From this I can take, I already said you, m is equals to tan theta. So if it is tan theta 1, I'll take it as m1. If it is tan theta 2, I'll take it as m2. From this you can clearly say that m1 is equals to m2. Okay, see the slope of this line is m1, slope of this line is m2. Okay, so slope of two parallel lines are equal. So slope of two parallel lines are equal. So m1 is equals to m2. So next thing is slope of perpendicular lines. Okay, so slope of perpendicular lines. Slope of perpendicular. I'm telling you this, these derivations are not at all important, but the relations are very, very important. See, this is very, very important. Okay, the relations are very important. Okay, so slopes of perpendicular lines. See, I'll draw two perpendicular lines. What is perpendicular in the sense? The two lines are perpendicular. If it is said that two lines are perpendicular, that means angle between them is 90 degree. Okay, so angle between them is 90 degree. See, this is y-axis, this is x-axis. Now I'm going to draw two perpendicular lines. Okay, I'll take this angle to be theta 1. Take this angle to be theta 1. Okay, this angle is 90 degree. So that is where, that means these two lines are perpendicular. Okay, so what is this angle going to be? I'll take this angle to be theta 2. Okay, so I'm taking this angle as theta 2. So see, from this you can clearly see these two lines are perpendicular. Now we have to see how these lines are related. Okay, so I'll name these lines. This is A, this is B, this is C, and this is D. Okay, so line AB and line CD are perpendicular. Okay, see, so I'll take slope of line AB is equals to m1. So m1 is nothing but tan theta 1, is it? So the slope of this one is slope of line CD is equals to m2. Then see, CD line is m2, the angle which is inclined is theta 2, that is m2 is equals to tan theta 2. Okay, so how this is going to be related? So I have to take theta 2. Okay, I have to know what is theta 2. So for that look at this diagram. See, you can see these two lines are perpendicular. Okay, so that means the angle between these two lines are 90 degree, and these two lines are parallel. Okay, if this doesn't seem to be parallel, please don't mind this. I meant to draw a straight line. Okay, so this two lines are parallel. Okay, now these two lines are parallel. That means this angle and this angle are same. Okay, so this angle and this angle are what? Same. So if this is theta 1, this is also going to be theta 1. Okay, see, listen to this concept carefully. For any two parallel lines, if there is a transversal cutting two lines, okay, this, if this angle is 1 and this angle is 2, see, angle 1 plus angle 2 will be equal to 180 degree. Okay, so see, here these two lines are parallel. Okay, so this angle is 90. If I add these two angles, that means this angle and this angle, if I add, it should be 180 degree according to this concept. According to this transversal cutting two parallel lines, according to this concept, angle 1 and angle 2 should be how much? 180 degree. So since this is 90 degree, this definitely should be 90 degree. Am I right? Yes. So this is 90 degree, this is also 90 degree. See, from this figure, so this complete angle is what we are calculating. This complete angle, right, is what we are calculating. Okay, so see this complete angle. Okay, for this diagram we had a parallel line here, but we have to calculate this complete thing. So theta 2 is nothing but, is it 90 degree plus theta 1? If we add both this, will we get this? So theta 2 is equals to 90 degree plus theta 1. So from this, how we calculate? See, theta 2 is equals to 90 degree plus theta 1. Taking tan on both sides, tan theta 2 is equals to tan 90 plus theta 1. So tan 90 plus theta 1. So we know tan 90 plus theta. Tan 90 plus theta is nothing but minus cot theta. Okay, so tan 90 plus theta is nothing but minus cot theta, and this is, so tan theta 2 is equals to minus cot theta. This is from the basic rules of trigonometry. Okay, so how it is? So tan 90 plus theta, in a sense tan 1 into 90 plus theta. Since 1 is odd, so tan will be changed into cot, and tan in second quadrant is negative, so minus cot theta 1. So tan theta 2 is equals to minus cot theta 1, and we know cot theta and tan theta are reciprocally equal. So tan theta 2 is equal, so I'll take it as 1 minus 1 by tan theta 1. Okay, so from this, if I make cross multiplication, I'll get tan theta 1 into tan theta 2 is equals to minus 1. From this, we know tan theta 1 is nothing but m1 into m2 is equals to minus 1. So slopes of perpendicular lines. Okay, so slopes of perpendicular lines is nothing but the product of their slopes is equals to minus 1. Okay, see here, the slope of AB is m1, the slope of CD is m2. since these two lines are perpendicular, product of their slopes is equals to minus 1. That is, m1 into m2 is equals to minus 1. So this is what you have to be careful in this chapter. So m is equals to tan theta. This is slope. Okay. So m is equals to tan theta is slope. Then slopes of parallel lines is equal. m1 is equals to m2. Slopes of perpendicular lines, in the sense product of slopes is equals to minus 1. So you have to keep these two in mind. All these four concepts in mind, so you will be able to solve the problems from the straight line. Now, slope of the line joining 2 points. See, before going into the line joining 2 points, I'll like to explain what are points. See, in coordinate geometry, always points, in the sense it will be named like P, A, B something. For example, I take this to be A. These points will be represented in the form of x, comma, y. Okay, x, comma, y. So this is the point. So first it will have x coordinate and then the y coordinate. Okay, so for single point. Okay, so they're saying slope of line joining 2 points. For example, see, if it is 2, 3. Okay, if it is 2, 3. Okay, so this is a point. So this point, I said, first it is x coordinate and then it is going to be y coordinate. For example, see, this is y axis and this is x axis. For example, this is 1, this is 2, this is 3, this is y1, this is x, this is 1, this is 2, and this is 3. Okay, so if I have to plot this point here, first I have to see 2 in x. So okay, 2 in x, point is going to be somewhere here. Okay, somewhere here. Then I have to see 3 in y. So I have seen 3 here, so point is somewhere here. So at intersection of these two lines, so the point lies here, that is 2, see, 3. This is how it is the point mentioning in the coordinate system. Okay, so 2, 3. Similarly, if you want to find slope of line joining of any 2 points, for example, see, I have a point here, I have a point here as well. So I have to find slope of the line joining these 2 points. So this is the line which is joining these 2 points. So one point is A of x1, y1. I'll take it like this. Since I have 2 points, P of x2, y2. Okay, so if I have to find the slope of this line, okay, so I have a formula straight away, that is m is equals to y2 minus y1 by x2 minus x1. Okay, this is the formula for slope of the line joining 2 points. Okay, you have 2 points and you have a line joining those 2 points. So one point is A of x1, y1, another point is B of x2, y2. Then slope of this line, okay, this line, slope of this line is y2 minus y1 by x2 minus x1. For example, see, I'll give you an example. If it is asked A of 4, 6 and B of 2, 8. Okay, these 2 points are given. If they ask you find slope of line joining 2 points. If they ask you like this, then see, 2 points are given. Now, which formula you have to use? This is the formula we have to use. For that, first I'll take point A, it is 4, 6, and point B, it is 2, 8. Okay, I'll take this as x1, this as y1, this as x2, and this as y2. So from this I can write x1 is what? 4, x2 is what? 2, y1 is what? 6, y2 is what? 8. So applying this in this formula, so slope of AB is equals to y2 minus y1 by x2 minus x1. Okay, so y2 is what? Is 8, minus what is y1? Is 6, divided by what is x2? It is 2, what is x1? It is 4. That means 8 minus 6 is 2, 2 minus 4 is minus 2. So 2 and 2 gets cancelled, so the answer is minus. So you'll get 1 by minus 1, so 1 by minus is nothing but minus 1. So slope, so m is equals to minus, so slope of AB is nothing but minus 1. So this is how it is. So when 2 points are given and you are asked to find the slope of line joining of those 2 points, so you have to use this formula, m is equals to y2 minus y1 divided by x2 minus x1. Thank you.